Hello friends, in today's question, a U-shaped tube contains a liquid of density rho and it is rotated about the line as shown in the figure. Find the difference in the level of liquid column. So this we have a U-shaped tube rather, and it is consisting of the liquid of density rho, and the height difference of the liquid is capital H, and the length of the base of the tube is L, and it is being rotated about an axis which passes through, let us suppose this we called as a left side and this we called as a right side, left arm as well as right arm. Okay. So let us call this as left arm and this we are going to call as a right arm. So herein, as it will be rotated with respect to this axis, this will be exerting a centrifugal force on the right arm because it is farther from the axis of rotation, and because of this there will be further difference in the height of both the liquids. And we are going to find out the amount of the pressure at the base of the liquid because of the left arm, and at the base of the liquid because of the right arm, and we are also going to add the effect of the centrifugal force. And if the pressure at the base we can say, if the liquid is in equilibrium, the pressure at the base will be equal, and we are able to find out the difference in the height of the liquid column, that is capital H. So let's start by stating that when the U-tube rotates, when U-tube rotates about vertical axis, and let us call this as a x and x prime for the sake of convenience, x and x prime. The element in the right arm, or we can say the liquid in the right arm, which we also called as a farthest from the axis, x prime feels a greater outward centrifugal force, centrifugal force as compared to left arm. Because left arm is nothing but very close to the axis, or we can say left arm and the axis almost coincide with each other. So the entire centrifugal force will be on the right arm itself. Therefore, we can say this causes a difference in height. Of the liquid columns in two arms. So we are going to find out the pressure at the base of both the arms. Okay. So let us first of all find out the pressure because of the left arm, and we assume that this left arm is having a liquid of height h1. So obviously up till here, the right arm is also going to have a height of liquid h1, and further height will be equal to h. So right arm is going to have a total height of, so left arm we had taken this height as h1, so therefore the right arm is going to have height h1, which is almost to the level of the left arm, and the additional height is given as capital H. So total height of right arm will be equal to h plus small h1. So we start by pressure at the bottom of each arm. Pressure at the bottom of each arm. So we are going to start with our left arm. Left arm is near the rotation axis. Near the rotation axis, and we assume that the height of the liquid column is h1. Height of liquid column is our h1. Therefore, pressure at the bottom, of left arm, let us call this as P left, will be equal to rho g h1. And similarly, this was our left arm. Now we do similar analysis for our right arm, and right arm is our, we can say, farthest from the rotation axis. Farthest from the rotation axis, which we called xx prime. Let me write here also xx prime. And the total height of the liquid on the right arm will be equal to capital H plus h1. Total height of the liquid in right arm, let us suppose that is h2, and that will be equal to h plus h1. Therefore, pressure at the bottom of the right arm, pressure at the bottom of right arm, let us call this as P right, which will be equal to rho g h2. Substituting value of h2, we get this as rho g and we h plus h1. This is our pressure right at the bottom. Now, effect of the centrifugal force, because the centrifugal force is going to further create the difference in height. Effect of centrifugal force. So as the tube rotates about the axis xx prime, as the tube rotates about axis x prime, centrifugal force creates a pressure gradient along the horizontal distance between the two arms. As the tube rotates about the axis x prime, the centrifugal force creates a pressure gradient along the horizontal distance L between the two arms. Along the horizontal distance that is given as L between the two arms. Between the two arms. So this results in additional pressure and further causes the height difference in the two arms. This additional pressure due to rotation causes difference in liquid height between the two arms. Difference in liquid height between the two arms. So in this case, we are not going to actually calculate the, you can say, difference in the liquid height, because whatever difference in liquid height will be there, it will be resulting in additional pressure. So we are going to calculate the additional pressure that will be the representation of the difference in the liquid height. Okay. So let us consider a horizontal arm, and that length of the horizontal arm is given as L, and this is the axis of rotation. We have x prime rotated with the angular frequency omega, and here we consider a small, you can say, liquid portion of width dr, and it is at a r distance from the axis of rotation. And we have the tube will be something like this, which we are not interested in the tube actually. We are only interested in the pressure gradient which will be created in the horizontal tube. So we say for a small element, consider a small element dr at a distance r from the axis of rotation, x prime. So we can find out the centrifugal force per unit volume of the you can say on this element. So we can find out centrifugal force per unit volume on the element, on this element rather, and that will be equal to rho omega square multiplied by r. And if the pressure difference is dp, then you can say the pressure difference dP at a distance r due to the centrifugal force then this dP can be written as rho omega square r multiplied by dr. So then we found out the pressure difference because of this small element. We can find out now by integrating the pressure difference for the complete length L, starting from r is equal to 0. This point will be our r is equal to 0, and this will be equal to r is equal to capital L. So we write total pressure difference between left and right arm, between left and right arm, that is from r is equal to 0, which is our left arm, up till r is equal to capital M, which is our right arm. So let us call this as PC, pressure difference due to centrifugal force, and that will be equal to 0 to L, and we have here rho omega square r and dr, and which will be giving us rho omega square L by 2. So this is the pressure difference that is being created by the centrifugal force. So we have, you can say, 3 pressures now. One is the pressure because of the left arm, another is the pressure because of the right arm, and the third is the pressure that is being created because of the centrifugal force. Now the entire system, or we can say entire pressure, or we can say pressure balance equation, our system is said to be in equilibrium. So we are interested in pressure balance equation. Pressure balance equation. So the system to be in equilibrium, or the system to be in equilibrium, the pressure at the bottom left plus the centrifugal pressure difference should be equal to pressure at the bottom because of the right arm. We can say that pressure at the bottom of left arm plus centrifugal pressure difference, centrifugal pressure difference should be equal to pressure at the bottom due to right arm. Pressure at the bottom of the right arm. So which basically means that we have pressure left plus pressure difference due to centrifugal force, and we have here pressure at the bottom because of the right arm. So we substitute the values. Pressure left is our rho g h1 plus centrifugal force we just calculated is half rho omega square L square, and pressure due to right will be equal to rho G. We have a capital H and plus H1, and if we open it, this becomes rho G capital S, and this becomes about rho G H1. So we can cancel the rho throughout the equation, and here also. So we are left with here GH1 plus half omega square L square is equal to GH plus GH1. GH1 and GH1 also goes away, so we get the height H will be equal to 1 by 2 omega square L square divided by G. So this was our question, that find the difference in the level of liquid column. So this is the difference in the levels of liquid column. Levels of liquid column. So here the important thing only is this equation. The pressure at the bottom of the left arm plus the centrifugal pressure difference will be equal to pressure at the bottom of the right arm. So this completes the question. Thank you.